Alright, now there are three flappy parts to this. We have what is a parabola, standard form, and vertex form. These last two we're not doing today. We're only working on what is a parabola, right? This may be a new shape. Has anyone seen a parabola or knows of a parabola? Ever seen a pre-algebra maybe? Alright, so a couple of kids. Pre-algebra?
Algebra 1.
Alright. Go ahead and open up what is a parabola. Open up that part. Now I stapled this and I thought I did some good work, so hopefully the foldable doesn't turn out terribly.
Good job.
Thank you.
This should be the graph piece like a little bit incomplete. Right?
Yeah, it got messed up over here, so we're gonna work on trying to complete that. Okay, so quadratic functions make a U shape. It's called a parabola. So there are two things: an equation and a graph. All right. If it's an equation, we say that that is a quadratic. And the graph, the actual shape of it, this U shape, we call that the parabola. These two things mean the same thing. It's just different names for different representations of it, right? Quadratic equation, parabola is a graph. Now over here we have what we call as our parent function, which is f of x equal to x squared. That's the thing that we just did. Okay. We're going to go ahead and put the table over here. So we're just replicating what we did on our whiteboard. So x goes on the left-hand side. And on the right side, this is technically y. But we're going to put f of x. F of x means the same thing as y. These are all outputs. Okay. And for the inputs, the values that we used were -3 to +3. So -3, -2, -1, 0, 1, 2, and 3. And if you can, go ahead and put the outputs that you found on your whiteboard. Alright, you can also look at the list of squares on the board. And once you have that, try to graph those points. Alright. What is the output when the input is -3?
9.
9. What's the next one?
4.
4.
Next?
1.
1.
0.
0.
1.
1.
4. 9.
4, 9. Now, the outputs, this is what we call is a palindrome. You probably hear about palindrome in English. But what do you guys think is a palindrome? Or we have 9, 4, 1, 0, 1, 4, 9.
Some sort of math thing.
Like, here's an example, I guess, in English of a palindrome. Like, mom is a palindrome.
Oh, it goes backwards.
Emma?
Oh, like mirrored?
It's mirrored, right? Like, if I drew like a line down there, it would be mirrored.
So like race cars.
Race car is a palindrome.
So is Hannah.
Taco cat.
Taco cat is a common one.
Hannah's a
Dakota?
how you spell it.
Oh, race car? So it's a word that if you spell forwards and backwards, right, it gives you the same word.
Bob.
Dad, Bob.
Hannah.
Right, many times students will say poop. Like,
How about
anyway,
pop?
it is a palindrome. Okay. So there's a reason that this is happening, and we're going to look at the shape of it as well. Go ahead and graph these points if you haven't done so. -3, 9. It's going to be hard to look at this. Just do your best in estimating where that point is at. But -3, 9 is 3 to the left and 9 up. I think that's a good point for -3, 9. -2, 4. 2 to the left and 4 up. Next one is the coordinate -1, +1. -1 is 1 to the left. +1 is 1 up. 0, 0 is on the origin. And then this stuff to the right, it's mirrored, right? We have this shape right over here, for this points, 2, 4, and 3, 9. And with this, as best you can, try to draw a parabola through those points. Right? It should be a nice kind of curve, there shouldn't be any corners, any like angles. Like this looks like a U. It looks like a combination of a V and a U. This will always constantly go to the left, and this part will always constantly go to the right, even though it looks like it's going straight up. Okay. Right, even here, it's supposed to curve. Maybe my drawing isn't the best. But I like to think of this as a combination of a V and a U. That is curved. Well, that's perfect. There you go. Terrible. Okay, alright.
It should be this one.
That looks pretty good too. Anyone else who would like to show theirs on here? Okay. Alright. And there are going to be other things that we talk about. I'm going to take out a different colored pen. A blue pen. Now, Emma talks about that this thing is mirrored. I'd like you to draw a vertical line through, well, in this case, it's through the y-axis. You can't really see it. But this is what we call our axis of symmetry. Why would I call this the axis of symmetry?
Is that what you call it? Oh my god. I don't
Well, this is not what I call it, but it's called axis. Why would we call it axis of symmetry?
Because if you cut it in half, then it would be symmetrical.
Good. If we cut this like directly in half, it's symmetrical. Like if you flip it, it's the same thing. Just like if I were to, not that I would, but like draw a line straight down my face, the right side should match my left side.
You should do that.
Not my brother though. My brother has like a scar that's like on the right side. I guess if you did that, it would like be a scar on his left side. Be like some
You should
ogre.
do that.
Okay. Now, this line, it's a vertical line. The equation of this line. Now, whenever we have an equation of a vertical line, it's always x equal to a number. And it's always where it crosses the x-axis. Now, the x-axis is right over here. It crosses it right over here. What number does it cross at? 0. So we say that the equation of this axis of symmetry is x equal to 0. You're right. Like let's say we had a parabola somewhere over here, and I have the axis of symmetry right there. Let's say right there. This would be the equation x equal to -7, because that's where it crosses. That's where it's symmetric at x equal to -7. All right.
But x is always equal to 0, right?
Well, for this one it is, but it could be shifted. It could be upside down. It could be moved, like shifted left and right. So it could be a different one. And we're going to practice that. Dakota?
Could you have a parabola that's sideways?
You could have a parabola that's sideways, but it wouldn't be a function, right? It wouldn't pass the vertical line
Yeah, it
test.
wouldn't be a function.
Yeah. But it's possible. All right. A couple things we need to talk about is this point right over here. Now, that's the origin. On the parabola, though, we call this is our vertex.
Guilty.
Like, I had a math teacher who always said, like, he looked like Colonel Sanders, but he always said that this was like the vertex. And I was like, you saying that way cool. I'm not going to say it like vertex, but it's the vertex. Vertex is just the turning points.
But
The vertex. Yes.
the way I remember vertex is I remember it kind of looks like a tornado and that'd be the vortex.
Oh, the vortex? Oh, that's
Be the
interesting.
vortex, the center of the tornado.
Okay, I never
Hey,
know that.
I'm tornado.
So don't put vortex, but that's a good way of remembering. So turning point of the parabola. Okay, good. All right. Going to go to the yellow part. We're going to go way down over here. Now, there are two types of parabolas, and it all depends on a specific value.
I know this one. If it's positive, it should be up. If it's negative, it should be down.
Perfect. There you go.
Ta-da!
That is why there are smiley faces.
I like the faces better.
All right, here we go.
I like the faces better.
I'm going to draw a parabola, something like that.
That's a big parabola.
That's a good parabola. Look at that. I'm putting the vertex right over here. So, right, good, John. Right, it deals with this A value. We're saying that this is positive. Notice how I put a smiley face over there. If this value is a positive number, it being 3.57, okay, the parabola will face up. Right, A is greater than 0. If something is greater than 0, it's positive. Right, so it looks like a smiley face. Now, there are a couple of things that we're going to label from this. First of all, this thing right over here, this is the vertex. And when A is greater than 0, we call this vertex is very specific in that it's what we call a minimum vertex. Any ideas why this is called a minimum vertex? Why wouldn't I call this? What do you think the other name? Instead of minimum, it would be?
Maximum.
Maximum. Why is this a minimum rather than a maximum? Below the x? Now, it's possible for me to draw this, though. Right, that's below the x-axis. Alright.
It's the lowest point.
Say again?
It's the lowest point.
It's the lowest point. Right? Whenever it's at the very bottom, I like to think of this as being a ditch. It's at the very bottom of that ditch. Okay, good. So if it's ever at the bottom of it, it's the minimum. Alright, a couple of things right over here.
But hold up.
These 2 points, where it crosses the x-axis, any ideas what we call that?
Vertex medium? Vertex medium?
Vertex? No, it's not any vertex.
What is the meaning?
Point of intersection.
Point of intersection. What do I call when a line or something intersects like an axis?
It's the axis of
X-intercept.
symmetry. The
Not the axis of symmetry. Say it
X
again?
intercepts.
X-intercept.
I said that.
It's right there.
Alright. Oh, where does it say?
They didn't listen.
It says
It says it right there on the screen. Your
Cheated.
computer covered.
Oh my gosh, it says it right there. Okay.
Cheater. Cheated. Yeah.
Alright, this is the x-intercept. I did not see it there. Oh yeah, that's why I wrote it. Okay. Oh, because there are other names for x-intercept.
Wait, hold up.
Alright, hold up. It's gonna have different colors. These ones got different colors.
You're wasting time on the video.
Oh yeah, that's right. Cool. Okay. So there are other names that we're going to work with on other things that you can call x-intercepts. We're not going to learn this right now, but just so you have an idea of what these things are called. So AKA, what does AKA stand for?
Also
known as.
I said it
We
first.
could also call this
No one did.
solutions. We can also call this zeros.
You're losing battery.
And we can also call this roots. And we're going to talk more about this when we get to
Set up.
solving quadratic equations. Right? Instead of saying find the vertex, I say find the solutions, find the zeros, find the roots. All right, another thing.
Fun.
This point right over here,
Solution.
where the parabola crosses the y-axis. What do you think we call that?
Y-intercept.
The y-intercept.
That's actually not.
Right? Wherever it crosses the axis, when it crosses the y-axis,
Intercept.
we call that the y-intercept. Cross the x-axis, we call that the x-intercept.
So with the one up here, would that be with the y and the x intercept both be the same?
Both be at 0.
The y, the
And
x,
the
and the vertex.
And the vertex. Right.
Vertex.
Good. Alright guys, and this
That's interesting.
vertical line that goes straight through the middle of the parabola. You guys know what this is? What is that? Axis of symmetry.
So crazy. Why?
Alright, we're going to try to fit that in. And I'll put it in blue.
I cannot see, Mr. B.
Really?
Zeros.
Can you see that?
Minimum.
Where are you, glasses?
Axis of symmetry.
Oh, I actually
Gotta
spelled
be
that
kidding
right.
me. I cannot.
Well, it's also spelled up here.
Well, I don't care.
Alright, axis of symmetry. This would be x equal to a number. We don't know where this number is at, so don't worry about that. Okay. But we are going to practice on identifying these different parts of a parabola. Okay. Alright, we got everything over here.
Equal to.
Let's go and go off to the right.
What?
My face is
Wait, I didn't get that.
Never mind.
That is correct.
Never mind. Mr. B, do you like my face is better?
Big eyes.
I fixed them too. I I got them eyebrows and tongues.
Do you guys? Did anyone adjust the
Yeah, I did.
base right there?
I gave you guys some
I
mad
give them
eyebrows.
eyebrows and tongues. That's all.
I guess I'll give him unibrow and
Looks like Charlie Brown.
got a mustache.
This will be this
Yeah, it doesn't look.
Stick out the tongue.
All right, go to the right, please. When a is negative, right? When this a value is less than 0, okay, it is not going to be facing up. Rather, it's going to be like that basketball video that we saw, where it's going to go up and then down. Okay, so go and draw a parabola. Something looks like vaguely like what I'm drawing. Just a U.
Upside down.
It's an arch. Noisy.
Okay. All right, guys. The only part that we're really going to talk about is that, yeah, this is the vertex, but what type of vertex is it?
It's
Maximum.
Maximum. Maximus. Okay, maximum.
Maximus.
Alright. Now we could identify, yeah, it's got x-intercept, yeah, it's got y-intercept, axis, symmetry, all that stuff. But you should already look at the information on the left-hand side, right? This part. For that, this is a bunch of writing.
Yeah.
This is a little bit more clean.
Can I just put zeros in?
If you want to label these, you can. Alright.
Sure.
But that's going to be the end of our notes.